This is FNC 311, Managerial Finance or Corporate Finance, Chapter 3, Perpetuity and Annuity. Agenda: in this short video, I'll discuss the following topics. Topic number 1, definition of a perpetuity. Derivation of the present value of perpetuity, method 1. Topic number 2, derivation of present value of a perpetuity, method 2. Topic number 3, definition of growing perpetuity. Formula for a present value of a growing perpetuity. Topic number 4, definition of annuity and derivation of present value formula for a given annuity. Topic number 5, Excel function to estimate present value of a given annuity. Topic number 1, definition of perpetuity. Simply type .uu. I have generated a utility function called explain, okay, with extension, with a shortcut .e. The shortcut is .e. Okay, so .e. And currently there are 17 explanations. So let's look at number 4, definition of perpetuity. Okay, so enter number 4. The definition of perpetuity has 3 components. Same amount of cash flow, happen at the same interval forever. For example, $500 each year forever, $10 each month forever. So actually, same amount of the cash flow, same interval, and forever. Okay. Below, I have 3 cases. Okay. Case number 1, we receive cash flow today, and end of first period, end of second period, forever. So this is case number 1. And case number 2, the first cash flow happened at the end of first period, at the end of second period, forever. Actually, case number 2 will be our focus when we derive the present value of perpetuity formula. So let's look at case number 3. So case number 3, the first cash flow happened at the end of nth period, and all case number 1, number 2, number 3, they are all perpetuity. However, we are going to focus on case number 2. The first cash flow happened at the end of first period. Topic number 2, derivation of present value of perpetuity. And so this is number 5. Okay, .e number 5. Okay, I just mentioned for the definition of perpetuity, we have 3 conditions: same cash flow at same interval forever. Okay, now we add another condition. The first cash flow happened at the end of the first period. So this is our cash flow pattern. This is timeline. The first cash flow happened at the end of first period. Okay. Okay, I'm going to copy paste to this one. Okay. Okay, so let's look at here. So what is the present value perpetuity? It is simply, there is a space. Present value of perpetuity is present value of first cash flow plus present value of second cash flow plus present value of third cash flow, and continue this way. So this is definition of present value of perpetuity. Okay, I'm going to copy this one. So this is equation number 1. Okay. From the previous, we know there are 2 functions. We show the future value equals present value times 1 plus r power is n. Okay, so this is, so another function is the present value equals, and future value discounted by n period. Okay, to derive present value of perpetuity, we simply apply this function to calculate present value of one future cash flow. Again, so this is definition of present value of, this is method we calculate the present value of perpetuity. Okay, so let's call, so again, the next item will be same cash flow discount by full period. So let's call the equation number 1. Okay, so both sides, so multiply both sides by 1 plus r. Okay, and because we only times 1 plus r, the value of equation will not change. Okay, so let's call equation, okay. Okay. So left hand side times 1 plus r. Okay, so 1 plus r, and so this is original right hand side. Okay, so actually the first 1 plus r can cancel with this one. So I'm going to just make it very clear. So let's just simply type 1 plus r first. Then I'm going to simplify this 1 plus r. Okay, so this continue this way. So next item with same numerator, and sorry, it's c times 1 plus r, the power will be 4. Okay, so this part we can simplify. So we can simplify. I'm going to delete this part. You see, 1 plus r and 1 plus r can cancel. Okay, I'm going to, so we only have c. The first item will become c. Okay, you see the 1 plus r, power is 1. This is power is 2. Okay, so this is, we reduce power by 1 for the denominator. Okay, so this is reduce power by 1, so this becomes 2. Okay, so this power is 2. Okay, so let's call equation number 2. Okay, I'm going to put the equation number 1 and equation number 2 together. Okay, so this is equation number 1, and so this is equation number 2. Okay, I'm going to just copy present value times 1 plus r, so equals. Okay, this is so this is, you see the c, equation number 2, the first item is a c, and the second item will be power is 1. Okay, this one is missing. This is power is 2. Okay, so actually, so let's make this one quite similar. You see here, so the first item here is the same as this one. I'm going to make it quite easy to understand. Okay, I'm going to just alignment. Okay, alignment. Okay, so this should be plus. So this should be identical to this one. So c 1 plus r power will be 3. Okay, so this is equation number 2. Again, how to get equation number 2? We multiply both sides of equation number 1. We have equation number 2. Okay, we are going to use equation number 2 minus equation number 1. You see here, left-hand side minus left-hand side, right-hand side minus right-hand side. So if you look at here, right-hand side minus right-hand side, so this one, the second item cancelled. So this item will cancel with this one. This one will cancel this one. This will cancel this one. So eventually, equation number 2 minus equation number 1, we end up left-hand side 1 plus r minus left-hand side equal c. Why only c? Because this item, so this item was cancelled by this one. So this one, this one, this one, this one. Okay. So eventually, we have this final result. Okay. Then period present value plus present value times r minus present value equals c. Okay. Present value cancelled. Okay. Times r. So eventually we have present value times r equals c. Finally, we have our final result. Present value equals c over r. Okay, so this is a very, I think probably the simplest formula and for the finance. Okay, I repeat. Okay, if we have a perpetuity, same cash flow at same interval forever, if the first cash flow happen at the end of first period, then we can write a very simple formula for the present value of this perpetuity, c over r. Again, c and r should be consistent. What does it mean consistent? If c is annual cash flow, r must be annual interest rate or annual discount rate. If c is monthly, r must be monthly. So c and r should be consistent. Topic number 2, derivation of present value of perpetuity. Method number 2. For this method, so let's look at a formula before we discuss. So I'm going to make this bigger. Okay, suppose we have c, we can call the summation. Okay, a plus a times q plus a times q power 2 plus, sorry, a times q power 3 and continue. Okay, so actually this is a series. Okay, summation s equals a. So actually the first number is a, the next number always times q. Okay, suppose q is larger than 1. Suppose q is larger than 1, then we will have, so a will larger than a times a times a times a, then this is infinity. Okay, so we know because the second item is higher than a, the third item is higher than another a, this will be infinity if a is not 0. Okay, so let's look at another. Suppose q equals to 1. So q equals to 1. Then we have a conclusion already. So this is simply summation equals a plus a because q is 1. Okay, so q is 1. Then this is also infinity. Okay, so this is also infinity. Okay, so then we have a condition q is less than 1. Q is less than 1. Okay, so our condition, our result will be, this is the first value divided by 1 minus q. 1 minus q. Okay, so this is our formula. So let's call it formula 1. The formula 1. Okay. And so let's draw a square. Okay. So AS equals half plus 1/4 plus 1/8 plus 1/16 and continue. Okay. If we draw a square, okay, we color half, then we color a quarter, then we color 1/8 and continue this way. Eventually, we can cover the whole square. Okay, whole square. So eventually, this should be equal to 1. Okay. Okay. So actually, for this one, we can see this is the first number is half. Okay, and half times half. Okay, so this is a quarter. Okay, so this is half times half times half, and this is q squared. So actually q equals half. Okay, and if we apply the formula 1, then we will have S equals, okay, the A is half and Q is half. 1 minus half. So eventually we got 1. Then we just got 1. Okay, and so this is formula we can apply. Okay, okay, so let's look at I'm going to make it small, more space. I'm going to copy the formula for the present value of annuity, perpetuity. Okay. Okay, so this is our formula, right? So this is our formula, and for the okay, so this is our equation. So let's call the equation number 2. Okay, so on the right hand side, so this we can treat as A. With this one we can treat A, and so second one is A times Q. Okay, so I'm going to copy paste again, and you will see what is. So this is. Again, the first item we can treat as A. The second item is simply times 1. So this is 1 plus R. Okay. The third item will be same thing. Okay. So this is times. This is 1. This is square. This is square. 1 plus R. So I'm going to use this one, and square. Okay. Okay. So this is the first item actually is A. Q is 1 over R. Okay. We can simply apply this formula. Okay. So this is present value equals present value of perpetuity equals A divided by 1 minus Q. We simply apply the formula. Okay, so this is equals, because we know this one is, okay, yeah. So the top one will be C over 1 minus R. So this is A. So actually, I'm going to make it. So this is A. Okay. So divide by 1 minus. So this is again 1 So this is 1 divided by 1 plus R, 1 plus R. So this is A, this is Q. Okay, then the numerator times 1 plus R and denominator times 1 plus R. So numerator becomes C and denominator becomes 1 plus R minus 1. So eventually we got our final result. The simplest function is C over R. Okay. Again, so this is second method. We derive our present value of perpetuity. If you don't know how to derive this formula, it is fine. Just remember, okay, there are 4 conditions. So same cash flow, same amount of cash flow happen at the same interval forever. If the first cash flow happened at the end of first period, then we have the simplest formula. Present value of annuity equal C over R. Topic number 3, present value of growing perpetuity. Okay, I'm going to show the timeline and the cash flow. So this is a constant cash flow we discussed. Okay, so this is at the end of first period, the same cash flow C, 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 and at the same interval. The first cash flow happened at the end of first period forever. Okay, so this is a constant cash flow. Okay, so this is a typical example: $10 at the end of first period, another $10 at the end of second period, and continue this way. The growing, if the cash flow with a constant growth rate G. So this is our cash flow. Okay. Again, the first cash flow happened at the end of first period. Then the second cash flow is not C, it's C times 1 plus growth rate. So each of the next cash flow is 1 plus, it's the previous cash flow times 1 plus G. Okay, the G can be positive, can be negative, and if G equals 0, then this growing perpetuity will be same as perpetuity. Okay, so this is suppose the first cash flow is 10, the growth rate is 10%, then the first cash flow is 10, so this is 10 times, okay, I'm going to, so this is 10 times 1 plus 10%, so we have 11. Okay, and the number 3 will be, we have a power 2, then this is 12.1. So this is cash flow number 3. Cash flow number 4 will be power 3. So this is 13.31. Okay, I'm not going to derive the present value of growing perpetuity. And after you finish watching this video, I have a challenging task for you to derive. Okay, so this is the formula. Okay, the formula, the present value growing perpetuity equals C over R minus growth rate. Okay, C is the first cash flow. Again, C is not constant. Okay, cash flow are not constant. C is first cash flow. You can use C1. R minus G. Again, CRG should be consistent. So if C is annual cash flow, R must be annual discount rate, G must be annual growth rate. So CRG should have the same frequency. Topic number 4, definition of annuity and derivation of the present value of annuity formula. Okay, so let's look at the definition of annuity. It's quite similar compared with perpetuity. Same cash flow at the same interval for n period. So this is only different between the present value of annuity and the present of perpetuity. Okay, sorry. This is only different between the perpetuity and annuity. Okay, assume the first cash flow happened at the end of first period when we derive the present value of annuity. So this condition or the last condition, condition number 4, is the same. as the condition number 4 when we derive present value of perpetuity. Okay, here is our final formula. So this is our final formula. Okay, so actually you can easily remember this formula. I'm going to leave this one first. So let's go to Notepad. Okay, remember we have the formula. Okay, so the first one is the future value formula. Okay, so this is 1 plus r power is n. So let's call it, so this is equation number 1. Okay, so equation number 2 is the opposite of the future value. Actually, is present value. Okay, present value, this one. Okay, so this is 2. Number 3 will be present value of annuity. Okay, the present value present value of perpetuity. Okay, present value perpetuity actually is a C over R. Okay, so this is the simplest one. Okay, here we don't consider growing perpetuity, we only consider annuity. Okay, now we want to look at the present value of annuity. Again, perpetuity, same cash flow at the same interval forever, and for the annuity, same cash flow at same interval for n period. Okay, so actually we can combine equation number 2 and equation number 3 to get present value of annuity. Okay, the first thing is we write these two. Okay, so we copy equation number 3 twice, C over R minus C over R. Then we apply equation number 2. You treat C over R as future value. So this one divided by 1 plus R power will be n. Okay, I repeat. Okay, for present value annuity is combination of equation number 3 and equation number 2. I'm going to show you later. Okay, so you copy C over R first, then you discount the second C over R by n period. Okay, we collect term, so eventually we got so this is C over R, and so this is 1 minus, okay, so this is 1 plus R power is n. Okay, so actually this is our final formula. I repeat. Okay, so this is our equation number 1. We have a present value, we calculate the future value. So this is our equation number 2. We have a future value, we are given a future value, discount rate n, we calculate present value. So this is the present value of perpetuity. It's simplest formula. Our present value annuity actually is combination of these two. We write C over R minus C over R, then we treat the second C over R as future value. Then we discount by n period. Then we simplify, this will be our final result. Okay, so let's look at how to derive this formula officially. Okay, so let's look at a simplified. Assume n equals 5. Okay, so this is annuity. We have 5 equal cash flow. The first cash flow happened at the end of first period, and the second period and continue. The total we have 5 periods. Okay, so this is our original annuity issue. Okay, so actually we can imagine this annuity is the same thing as the 2 perpetuity. Okay, we receive cash flow at the end of each year forever. So this is first cash flow. Okay, And also we start to pay. Suppose we okay, so let's look at $10. Okay, then we are going to pay negative C at the end of year 6. Okay, so C forever, and the negative C. You see the positive C and the negative C, they cancel out. So the net result will be the present value of annuity. Because we have two perpetuity, then we can apply the present value perpetuity formula. Okay, so this is case number 1. We receive $10 at the end of each year for the next 5 years. So this is annuity. Then we can imagine we receive $10 at the end of each year forever. In addition, start from year 6, we pay $10. Okay, so $10, $10 year 6, $10, $10 year 7. They all canceled out. Okay, the present value of annuity is simply the present value of the first perpetuity minus present value of second perpetuity. Okay, so we can C over R. We know this is C over R, right? The first one, because we are standing at time 0, so it's C over R. Okay, the second one, because we are standing at year 5. Okay, second one will be C over R discount by n period. So eventually we can derive our final formula, the present value of annuity. Topic number 5, using Excel to estimate present value of annuity. Okay, so let's assume cash flow is 100. Okay, so let's use 10. And the number period is 5. Okay, R equals 10%. Okay, so we are going to receive $10 at the end of each year for the next 5 years. Okay, if the discount rate is 10%, what is present value? Okay, so equals present value. Okay, and so this is payment, actually is 10. Remember, so last time from the chapter 2, we know we enter 0 because we calculate present value of 1 future cash flow. Okay, so rate is 10%, number of the period is 5. Okay, the payment is 10. So actually, okay, I'm going to show the formula. Okay, tax formula. Okay, I'll make it bigger. Okay, again, because we enter positive future value, the present value will be negative. So red in the parentheses is negative value. Okay, the first value is R, is rate, is 10%, is C4. Next period is number period. The number 3 is payment. So actually a constant cash flow. So this is the present value to calculate. So this is we can use in Excel. Remember, we're using equal present value, rate, payment, and okay, I'm going to prime. Okay, remember, we use present value, rate, and number of the period, 0, future value. Okay, so this is a formula we calculate present value of 1 future cash flow. Okay, so this is formula we use calculate. Okay, so this is rate, payment. Okay, so this is equal present value, rate, number of the period, 0, future value. So this is formula we calculate present value equals future value 1 plus R. So this is for given 1 future cash flow. okay, for one future cash flow. So this one, we can also apply the present value rate, now the period payment. So this is equivalent to C over R times 1 minus 1 over 1 plus R. So the power is n. Okay, and so we can manually verify or calculate. Okay, so this is the present value 2. Okay, so equals, so this is C over R times 1 minus 1 over 1 plus, so 1 plus R, the power will be 5. Then we close it. Okay. Okay, so let's use the show the formula txt. We should get the positive value. Yeah, it's negative signs. Okay, so this is positive. Okay, so this is applied. So this is I called method 2. So this is I called method 1. Because method 1 is much easier, we apply Excel present value formula. Alternatively, we simply apply the formula to calculate the present value of annuity.
Shutterstock Music.